Hello everyone. Today I will be presenting the solution to question 1 from our end semester exam. The task is to find the root of the non-linear equation f of x, that is x square minus x minus 1 is equals to 0, using a numerical method. So I have chosen the bisection method to demonstrate this. The given equation is f of x is equals to x square minus x minus 1 is equals to 0. We aim to find a root of this equation numerically. The bisection method is a bracketing method which works by repeatedly dividing an interval in half and selecting the subinterval in which the function changes sign, ensuring a root exists in that interval. Secondly, the given equation is f of x. Then we aim to find a root of this equation numerically. The bisection method is a bracketing method which works repeatedly and by dividing an interval in the half and selecting the subinterval in which the function changes sign, ensuring root exists in that interval. After that, let me walk through the bisection method algorithm. Firstly, starting with two values a and b such that f of a and f of b have opposite signs. Secondly, compute the midpoint c is equals to a plus b by divided by 2. Then third, evaluate f of c. If f of c is close enough to 0 or the interval is sufficiently small, then stop. Otherwise, replace either a or b with c depending on the sign of f of c and repeat. Then after that, initial conditions are now applying it to our equation. We choose a is equals to 0 and b is equals to 2. Then f of 1 is equals to minus 1 and f of 2 is equals to 1. Then since f of 1 and f of 2 have opposite signs, a root lies between 1 and 2. Then after that, let's look a few iteration steps. Iteration 1, that is c is equals to 1.5, f of f 1.5 is equals to minus 0.25. That means root lies in 1, 1.5, and 2. Iteration second, c is equals to 1.75, that is 0.3125. Root lies in 1.5 and 1.75. Then iteration third, c is equals to 1.625, that is 0.0156. Root lies in 1.5 and 1.625. After that, iteration 4 and iteration 5, in which root lies in 1.5625 and 1.625. And for the iteration 5, root lies in 1.59375 and 1.625. After that, comes the flowchart. This flowchart represents the entire bisection method algorithm. We check if the initial interval is valid, compute the midpoint, evaluate the function, update the interval, and repeat the process until convergence. Then another slide is intermediate result table. That is, here's a tabulated view of the iterations with approximations, function values, and errors if needed. This helps us track convergence visually and numerically. After that, the eighth slide is geometrical interpretation. Geometrically, the bisection method works by narrowing down the interval where the graph of the function crosses the x-axis. Then each midpoint estimation gets closer to the root. Imagine zooming into the curve between two x values, watching the interval shrink towards the point where the graph intersects the x-axis. Then at each iteration, we can compute the absolute error as half of the width of the current interval. The bisection method has linear convergence. That means the error reduces roughly by half in every step. Though it converges slowly, it is guaranteed to find a root if the initial assumptions are correct. Then, for the conclusion, to conclude, the bisection method is a reliable and simple method to find roots of nonlinear equations like f of x is equal to x square minus x minus 1 through repeated uh, and interval checking. We narrow down the root with guaranteed convergence. Thank you.